Welcome to this video tutorial from spssvideotutor.com. I'm Jacob Mays, and today I'm going to demonstrate how to perform and interpret a dependent samples t-test. In this demonstration, I will use a data file called fearofstats.sav. It contains data from a fictitious study to test the effectiveness of an intervention program designed to reduce fear of statistics. Each student was given a fear of statistics test before the intervention program and the same fear of statistics test after the intervention program. Let's begin by examining if there is a significant difference in the fear of statistics mean scores before and after the intervention program. So the first thing that we do is we go to Analyze, we go to Compare Means, then we go to Paired Samples t-test. We see that our variables are on the left and we have a paired variables box on the right. So we take the two variables that we're interested in comparing and move them over to the paired variables box. So the first variable is FOST1, which is fear of statistics time 1, which is the pretest, and FOST2, which is fear of statistics time 2, which is the post-test. Okay, we go to Options. We make sure that this is set to 95%. We also want to make sure that under missing values, exclude cases analysis by analysis is selected. We click Continue, and then we click OK. In the output viewer, we first see the paired sample statistics table. SPSS gives you the mean, the number of cases in each group, or the sample size, the standard deviation for each group, and the standard error of the mean in each of the groups. Okay. SPSS also gives us the Pearson correlation between the two conditions. When repeated measures are used, it is possible that the experimental conditions will correlate, because the data in each condition come from the same people, and so there could be some constancy in their responses. So we see here in these results that it's a very strong correlation at 0.862, and this correlation is significant. And we say it's a very strong correlation because the correlation's coefficients range from -1 all the way up to +1, where the absolute value of 1 represents a perfect correlation. So this is a very, very strong positive correlation. The third table that we want to look at is the paired samples test. In this table, we have the mean differences between scores, which is simply this minus this. We have the standard deviation of the differences between the means, and the standard error of the differences between the participant scores in each of the conditions. We also have the confidence interval, the lower and upper level confidence interval, and the t value, the degrees of freedom, and the two-tailed significance level. To find out if there is a significant difference between the two test scores, we look at the column labeled significant two-tailed. If the value in the significant two-tailed column is less than 0.05, then there is a significant difference in the mean scores of the two tests. So to interpret the data, we go back up to the paired sample statistics box and we look at the mean scores for each of the two test periods. We see that the fear scores for the pretest on average were 40.17. We see that the mean scores after the intervention were 37.50. So there was a significant decrease in fear of statistics scores after the intervention. Okay? So basically the results indicate that the intervention program appears to reduce fear of statistics. Now remember, you can never say that the intervention caused the reduction in fear in statistics because there are so many other factors that could explain that. Okay? So now you know how to run a dependent samples t-test. If you have any questions, please submit them to jacob@spssvideotutor.com. This has been an SPSS video tutorial from spssvideotutor.com. Thank you for watching and much success with SPSS.